good morning, good afternoon, and good evening to all our viewers from around the globe. We are very thankful and we're lucky to have you guys as viewers. Today, my name is Ronit Mukherjee, and I'm an industry process consultant here at Dassault Systems. And today with us, we've got Greg Albertson, industry process expert here at Dassault Systems as well. And Greg, thank you for joining. I know I'm super excited about this episode. I'm a big fan. I know we've got a lot of different viewers out there that are very they're super fan of yours as well. So the knowledge that you share with us and it's phenomenal. It's like really industry specific knowledge. So it's for product development and how we incorporate the tools here at Dassault Systems into the engineering world. So thank you for that.
Yeah.
For our new viewers, could you please give a 2-minute background on where you come from, what your expertise is, and just a little bit for our new viewers.
Yeah, let us know. That helps us tailor, what we say. These are definitely presentations that are off the cuff. We have material we want to present, but we want to know about you guys, and so in future episodes we can incorporate, some of your comments, questions, and interests as well, for sure.
Brilliant.
Yeah. And as far as my super
right,
fan, that's got to be my mom. I don't know if my mom knows how to use YouTube though, so.
No, but of course, everyone's mom is super fan all the time. Our moms are going to be about our best fans we can. But there's a lot of viewers out there as well that are super fans. I keep getting the word, hey man, Greg's got this information. Can we please get it from them? So we are super fans of you. So I know that doing a little bit of recap of what we have discussed in the past, and this is a YouTube series that we are doing. The simulation, what's new, simulation and the 3D experience. We've done 2 episodes in the past. They were combined. And can you give a little bit of a recap of what we discussed in those previous episodes and what for us in today's episode?
Yeah, sure. So, again, these live sessions are short sessions. Our last one, we combined 2 sessions, session 1 and session 2. So it was an hour long. Today's only going to be about half an hour. So hang with us. In the last session, I went through a general process of creating a simulation. So what we have is, we have a series of different presentations that we want to give, and we're going to go through the creation and simulation of a mountain bike. So we're going to go through, injection molding, structures, fluids, EMAG, all these different types of things through the whole series. And so last time I just went through a brief overview of creating a simulation, what it takes to take something from SolidWorks, put it into 3D experience and create a simulation. And Sagar, my co-teammate, he went through and showed a little bit of how we incorporate that into the dashboard and how we can view some of this material and some of these simulations in the dashboard as well. So, I encourage you to go back and look at the previous YouTubes and do that. And these models are available for you to download and try out on your own as well. So
that's brilliant.
That kind of gives an overview. Yeah.
That's great. That's great. Guys, a big shout out to Sagar. He's on the backgrounds working. He's producing this live for us. So again, a fantastic industry process consultant here on our team as well. So also, we want to keep this live series very interactive with our viewers. Please send us all your comments and questions, bombard us with stuff, and we'll do our best all of them in a timely manner. So since it's a quick session, let's get to it, Greg. See what you've got for us and what we can share with our viewers.
Yeah, sounds great. Thanks, man. So today, if you watch one session, watch today's really, because what I'm going to discuss today is basically how we bring models in from SolidWorks to 3D experience. And that may sound pretty easy, and it is, but the hierarchy or the structure and organization of models inside 3D Experience is very different than any other CAD package you've dealt with. And it's extremely powerful. And once you grasp the concept of what I'm about to show you, it's really going to open up a lot to your particular workflow. So, Ron, I assume I'm sharing my screen at this point?
Yes, I believe you are sharing your
Okay.
screen. You should be good to go. Before we start, one quick question. We've got a question from Marie Blanchard. You mentioned we can find these models and play with them. Where can everyone look for these download?
Yep. So we can share. Maybe we can share a link here at the end. But these are going to be available on the YouTube series website, and the link should be available there. I believe they're also available on the SolidWorks website, which navigates you into this whole series platform as well. So maybe we can capture that link and show it up here at the very end.
Brilliant. All right, that's good.
Perfect. Yep. So this first slide here, this is a quick overview of everything that we're going to show, over the next 12 months. We're doing this once a month, and we're going to go through a lot of stuff. So again, let us know if something interests you, something you'd like to see, and maybe we can squeeze that into some of these presentations as well. So
brilliant.
All right, collaborative designer, UES, PLM services. We have a lot of different terminologies that has been sent out for this particular part of the application. And really what it pertains to is this little 3D Experience plugin. And I showed this in the last presentation, but basically once you have this enabled, your SolidWorks software product will be connected to the cloud. And when you save your models, that will be stored up to the cloud. And then you have readily available access to that anytime, anywhere, from any location. So you can access those models. You can open them up here inside SolidWorks. You can work on those. And then when you're ready, you can directly open those up into the 3D Experience environment and add that other level of simulation fidelity to it. So, create those different types of simulations. And I'll get into some more details about that. Yeah.
A quick question on that. So the image that we are seeing, that's the SolidWorks window, and you've got the 3D Experience plugin within it. It's not a separate window within the SolidWorks window. Okay, that's pretty easy to handle.
Yeah, and I'll show the software. I'm not going to bore you guys with too many PowerPoints. Maybe I'll just try to bore you with a few of them. Yeah, no problem. But I'll show you live. Yeah. This is the slide that I really want to drive home today. So again, if you take anything away from this presentation, it's this slide. I mean, it's a beautiful slide. I mean, right? It's awesome. So what we have in 3D Experience is we have an organizational structure that are called representations. All right. So here's my mouse, right? This is the real mouse. That's the product. That's the real deal. Well, I can take a picture of that. I can grab my cell phone and I can take a picture of it. That's not the real mouse. It's a representation of the mouse. I could grab a piece of paper. I could draw a sketch. Again, it's not the real mouse. It's a representation of the mouse. I can create a 3D model of it. I think you get the idea, right? It's not the real mouse. It's a representation of the mouse. And we have that same kind of structure and that same kind of hierarchy inside of our modeling structure on the platform. So I'm going to create a part, and then I'm going to create a graphical representation of that part. And then I'm going to create a mesh representation of that part. What that allows us to do is a lot of different things. And one of those things is I can create meshes at different levels. So I can create the mesh representation of all my parts at a top level, but I can also open up each individual part and I can create a mesh at that as well. And I can combine that at the top level. So this is probably a little confusing right now, but it's going to be very, very clear once I launch the software to kind of show you, at any of these different levels. So at the assembly level, I can create a mesh representation, and at the part level, I can create a mesh representation, and then just include those connections or those interactions between all the different parts. And so we'll kind of go
Brilliant.
through and show
Listen,
some of that. Yeah.
quick question right there. So, in the simulation world, we hear the word mesh all the time. So we are
Yeah.
very familiar with what mesh is and types of meshes and this and that. For our new viewers, can you give a little bit of what mesh is? What do we need meshing for, and why is it
Yeah.
important?
Yeah, sure. So a mesh is basically a geometric discrete representation of what the geometry is. So if I have a block and if I create a mesh of that, basically what happens is I create a bunch of Lego blocks, whether they're cubes or whether they're pyramids, and I stack all those cubes and all those pyramids together from different sizes, but they're all pretty much either a cube or a pyramid, and I stack all those together until that stacking represents the final shape of what the geometry is. Just like Legos, right?
Got it. Got it.
Well, each one of those brick shapes, those cube shapes, or those pyramid shapes contains a point at each corner, and that's a node. That's a node at each corner. And just as we know from mechanical engineering, from a string, F equals kx, right? So force equals some constant times distance, right? So we know what our spring force is. That's really all finite elements are, is F equals kx. And each one of those little points, when I put a force on one point, it's going to move. And if I put a force on this point, it's going to move. And that k, that F equals kx, is really that representation of when this point moves, how does this point move? And that's really all finite elements are, is it's just a bunch of forces on some points. You push it, and then through that k value, it moves and pushes all these other points around. And I mean, really, in most simple forms, finite elements is just a big, gigantic spring equation. So hopefully,
That's very well explained, man. That's brilliantly explained. Mary had a question with us. What does FEM stand for? I think you nailed it right there. Finite element matrix. So thank you for that, Mary. But yeah, thank you for the quick explanation. Yep.
You bet. All right, so we have this model. We're going to open it up in 3D Experience. And so with the add-in, this is right inside of SolidWorks here. I went through a little bit more explanation in the previous presentation, but here's my assembly. It's represented directly here in SolidWorks. And if I want to open this up in 3D Experience, all I need to do is highlight that. I can go up to the compass, and then whatever sort of license or role I have access to, it's gonna show me that right here. So I could open this up directly inside of simulation, but I'm not going to do that today. My favorite thing is to open that up in collaborative lifecycle. It's kind of like a placeholder. If I open that up directly inside simulation, it's going to predict what those mesh sizes are going to be for me for each one of those parts. Okay. And it does a good job. It likes that, but I'm pretty old school. As you can see, talk about mountain biking and maybe some wrinkles or whatever. But I like to go through things a little bit more, my own process, a little bit more manual. So I like to open that up in what I call collab lifecycle. So all I do is I select on that button there, and then voila, I have 3D Experience launched in a separate session. Here is the
quick question on that. So you launched that collaborative lifecycle app, and it opens a window, this separate window that we are looking at right now, the Innovate 3D Experience window. Great.
Yep. Yeah. And so this is just, a different application. So this is 3D Experience, and here's SolidWorks back here. So here's the model that I opened up. And now all I need to do is go ahead and actually open it up in my actual session. So that transfer just brings it over into 3D Experience. And now I can go about opening that up directly right here in the software. You can see here's Collab Lifecycle. And now I have all the same kind of stuff. So I've got my directory tree over here, very similar to the directory tree that we have in SolidWorks, replicated inside the platform here as well. One of the
That
unique things
opened
that was,
fairly quickly, Greg. Sorry to interrupt, but like I was checking on the timer. That opened very quickly in this collaborative life cycle, and you opened it live, correct?
yeah. It's fast. It's super fast, even though this is on the cloud. So
Right.
I'm based in Colorado. The cloud that I'm actually using, I think, is based in Waltham. So I'm going across the other side of the country. I
Wow.
often work on a server in Europe as well, and it's super fast. It's pretty quick. And sometimes, once I open this up, if I close it, some of that is saved in the cache as
Okay.
well, and so it opens up a little bit quicker. Just double checks, make sure if there's been any changes or whatever, and it opens up right away.
Brilliant.
So yeah,
Quite
super
impressive.
quick. Yeah. So here we have the structure. We've got all the parts in that assembly here. One of the unique things about this is I still have the availability. So if I only want to create a simulation on the handlebars, I can open up this whole model inside 3D Experience if I want, because I still have the ability to come in here, and open up any of these in a separate, unique window inside 3D Experience, and just work on, some of these little sub-assemblies. So you can see here, here's this window with the full part, and just makes it a little bit easier to maybe work in a sub-assembly context. So let me just keep diving down there. I'm going to go ahead and open up the handlebar all on its own, all by itself right here. So
So
I've
you're
got,
isolating that particular component in order
yeah,
to run analysis. Okay, great.
yeah. And I can obviously work in the context of a full assembly, but sometimes, for whatever reason, I just don't want to look at everything, and I just want to do it on a single part. So there we have the single part. So um, remember my discussion about representations?
Correct.
This is what we have. This blue little Tetris part, that's the part. That's the mouse. That's the real part. This white one, that's the representation. That's when I took the photograph of it. That's what we call a 3D shape representation, and that's where all the geometry is contained underneath that little guy right there. Okay, so if we look, just due to time here, I've gone ahead and created a simulation because we only got pretty short amount of time.
Right.
Let me just open up this little part here by itself real quick. So what we have in this model, same handlebar, right? But we can see underneath here, I have some geometry, and this is all of the geometry that came over from SolidWorks. But the other thing that you'll notice is there's this little do not enter sign. And what that do not enter sign means is in 3D Experience, I am not authorized to modify the geometry because we're retaining the geometry authoring tool as SolidWorks. So you'll still do all your geometry manipulation, dimensions, parameters, changes, and all that inside of SolidWorks, and then we'll just use that inside 3D Experience. So the only slight difference to that is what I can do is you'll see this other thing that's called an abstraction shape. And what that abstraction shape is I have inserted basically an additional representation. So I have created this abstraction shape representation. And what that allows me to do now is I can come in here, I can copy that body from the SolidWorks, and I can paste it with link down here in my abstraction shape. And there's just a little bit of cleanup that I like to do because, again, I'm kind of particular, so I like to drag it there. So this shape is linked to this body. So any changes I make here in SolidWorks, those changes are going to propagate through to this body. And in turn, this body is going to put changes here. So why that's really cool is now I can go through and I could do a number of different things. So I'm just going to go ahead and switch to something called shape design. And I am going to insert what I call a geometrical set. And I'll call this surfaces for FEA. All right. What this now allows me to do is I can come in here and I can create an extraction. Let me just take, let me just do, grab this one, this, and this, pick that. I'm going to join those together. I know I'm doing a lot of operations here.
No, this is perfect. I mean, this is live, so we're in the software. This is what we do on a daily basis. So this is great to show.
So I'm going to hide this original shape representation, and I'm going to hide this one. So you remember this body came over from this body. So it's a solid, right? It's that solid. But what I just did is I did a surface extraction and created basically a shell.
Sure.
So now this one's not really a representation, so I kind of misled you there a little bit, but it's contained under a representation. And this is the extreme power that 3D Experience has, is I can have all these different types of shape representations and different representations depending on what I want to do at the simulation level. So if I wanted to do a defeature, if I wanted to remove some holes, some fillets, maybe I wanted to add some material just for a simulation evaluation.
Right.
Sometimes that's a little bit easier to do here in the platform because, if I modify here in SolidWorks, well, is this already in a drawing? Does it already have manufacturing data? Does it already have mates? So sometimes I don't want to actually modify my real part. I want to modify the representation of the part, right? So that's why this is so awesome, because now when I come over and I start to create my meshes, let me hide that one. I don't want to show that one right now. So let me insert a new, let's see, I want to insert a new finite element model. And so now we can see I have a new FemRep in here.
Yep.
And with that, what I can do now, I'm just going to click through some buttons here. What I can do with this mesh is I can say, hey, what do you want to mesh? So I could mesh that as my tetrahedron. So if I wanted to mesh that bar with tets, I could go ahead and do that. So there's my tets, there's my solids. I could have created a different FemRep, and maybe with this FemRep, I want to create, a shell mesh, right? So
this is absolutely powerful. Like, I can definitely see the benefit of having multiple of these different representation and creating multiple different meshes. Perhaps do a depending on what level of accuracy you want to go to. So this is powerful, and I think one of our viewers, Mike, kind of mentioned this as well. This type of methodology is used in photo editing workflows as well. We don't want to mess with the raw data. We want to be able to use those representations and work on those. So that's a fantastic comment, Mike. Thank you for that.
Yeah, Mike. That's I do a little bit of photography myself. So if you're talking about like Lightroom, where it's a non-destructive, so perfect. Thank you for that terminology. This is basically a non-destructive workflow of your original model. So this has not been destroyed. I can continue to create these other sort of edits to it in this workflow. And then the beauty is when I get to the level of creating my actual simulation, look what it does. It says, hey, which one of those meshes do you want to use? So I can pick and choose which one of these meshes I want to use. So we keep that congruity of everything connected together, that whole one source of truth, right? That one data source. And I've said this before on other presentations. I'm awful at organization, especially in previous lives when I wasn't using 3D experience and I was creating simulations. I would have a model, I would export a step file, I would mesh it. I'd be like, okay, I need to modify it. So I'd create a step file version 2. I'd remesh it. And then maybe in that mesh, I'd have a coarse mesh, a fine mesh, and then I'd create some results. And I have results 1, result 2, final results. And I'm like, oh, I need to change my model. So now I've got step version 3. And I've got final version number 4, whatever. And it's just a folder nightmare.
We've all been there, Greg. We've all been there.
I know, right? We're gonna have to all go to therapy together. So just takes care of it, right? I've got one model. I've got all the different geometric representations. I've got all the different mesh representations of it, and I've got the simulations. And I can query the database, and I can say, hey, where's this part used in which simulation? I can open up the simulation. My results are always accurate, up to date. And so really, if there's anything like to make you think about using 3D experience, man, it
definitely seems like it streamlines things. And a quick question we've got, one of our viewers, Sagar, he's asking the different mesh types that we use. I'm sure they affect the simulation results and their accuracy. How do they affect again, mesh is another topic that we can dive in for ages and ages and talk about it. But a quick answer to this, of course, does the mesh type affect the simulation results and their accuracy?
Absolutely, yeah. The mesh type would definitely affect the results. For example, so this model here, depending on what type of results I'm trying to get at, the temp mesh might be fine. And I may have a lot of people cringe that they're like, you're going to mesh that tube with a temp mesh? Sure. It all depends on what you're trying to get in the end. If really all I'm trying to do is I'm trying to create a method of force transfer, F equals kx. If all I'm trying to do is get a method of translating the force from here, from these handlebars back into the stem, temp mesh is probably going to be fine. Sure. Is it going to be accurate enough to tell me what my proper through thickness stresses are? No, it's not, because again, we can see that they're really not that great. That I would need more elements through that thickness. So then we would get into that discussion of, okay, is a shell mesh good? What I want to use this shell mesh? Yeah, the shell mesh is probably a good solution for that. Or what we can also do is I can actually create a hex mesh through the thickness here as well. So again, just depending on what type of simulation you're trying to solve, where your stresses are most important, those are all different key aspects. But what I want to, go ahead.
No, and of course accuracy matters as well, right? For some part, maybe you don't need to go that depth and that accurate, and maybe just a dirty mesh and just results are okay for that particular area. Maybe that's not as conclusive of an area or as important of an area.
Yeah, and one of the big things that I really like to point out is now proper loads, proper boundary conditions, materials, meshes, all of that is extremely important. But again, it really depends on what you're trying to do.
Right.
These tools can predict, the performance and the behavior of your models with extreme detail and extreme pinpoint accuracy. So, I can figure out if this was a carbon bar, with our tools, I could predict, if and where it's going to crack and when it's going to crack. But if if I'm a designer and I don't know how to lay up a carbon model, I don't know how to do delamination, that's okay. If even if I don't know what my loads are, like
Sure.
if I have no idea if this is going to be 300 pounds or 200 pounds, if it's a dynamic load or whatever, even if I don't know what my exact loads are, that's okay. You can use this tool as a design tool. So even if I put a unit load of 1 out here, what that's going to do is that's going to show me how the product's going to perform. It's going to show me where my highest displacement regions are, where my highest stress regions are. It may not be accurate stresses and displacements, but it's going to show me where, at least as a designer or somebody with limited simulation knowledge, it's going to show me where I can probably make changes, like what regions I should add material, what regions I can remove material, what changes did this make, making the bars longer, shorter, different angles, whatever. It'll help give me insight as a user, as a product developer, in how to better create this model. And then once I go through all that, then worry about the exact loads and stresses and things like
Right.
that. Yeah.
The fine tuning comes at the end, and
Yeah.
the structure comes in the all throughout the way. So that's fantastic. I know we are a little bit ahead of time. Oh, sorry, not ahead of time, past time. If you have more things to share, Greg, let's do a quick quick cap and for our viewers. By the way, I forgot to say this. If you're new to our channel, please like and subscribe for all latest and the greatest content with experts like Greg. We're here sharing all their knowledge, and there's so much to learn, so much cool content out there. So please like and subscribe us. Our channel, and yeah.
Yeah. I mean, that's really what I wanted to show. So unless you have some more questions, we're at the time. I just want the users here to really get a good idea and understanding of, how the structure is organized, how powerful it is, how we can just work in this non-destructive environment. I love that, man. I'm gonna steal that phrase, and I'll give you a nickel for every dollar I make off that phrase, but which will be nothing. Sorry, dude. Anyway, yeah, that's great. Just thank you so much. But yeah, anything else floating out there? I think we've tried to answer a lot as we've gone.
Like I was saying, the questions have been great from our viewers. You remember at the start of the session, I was telling you you've got fans. I'm telling you you've got fans. So Murray doesn't want the class to end, and then there were a few good ones as well. So we really want to thank you for your knowledge that you share with us. During this these YouTube live series. Now, I know that next month we've got another very fantastic session that's in place for everybody else. Can you talk a little bit about what this session is going to be?
I don't know. I don't know what the next session is. Sagar in the back room. Do you know what it is? I don't know what the next.
Yeah, it is. So I've got it. So I've got it on the screen.
Oh, okay, cool.
We're going to be talking about the frame, right?
Oh, yeah. Oh, that's me. Yeah, I'm giving another session.
I'm a month ahead, Greg. So I'm planning things a month ahead. So yeah, you, my friend. You'll be showing us how to design a good frame. I don't want this mountain bike to be breaking. And I've told you my experience with mountain biking. Yeah. So we're gonna make sure that frame is strong. Yeah. So that's what we're gonna be showing on the 19th of next month. Same time, same place. Please join us for that session as well. And we would really like to thank you for viewing this episode. Greg, are there any parting words you want to tell our lovely viewers?
No. Just I hope you guys are enjoying. These are fun for all of us. Again, just let us know. Send us emails, send us comments if there's more things that you want to see that might not be on the schedule. And yeah, that's it. This is for you folks. So let us know how we're doing. Let us know what you'd like to see, and we're going to keep doing this because I'm having a lot of fun with it. So this is great.
I'm excited. You can tell the excitement from my face, man. I'm like so happy when I sit in these.
I can't see your face. I don't have your.
Oh, okay, yeah. Well, I'll send you a picture later.
Yeah,
Okay?
send me a picture of your face. Yeah, right.
All right, guys. It's been fantastic. Thank you so much for being with us today, and until next time.